Now, I had posted some slides today, and it would be ideal if you take a look always on them, because these slides are very helpful to recall.
I also tried the topicals today, but there was like this one question about the density of like a hose of water hitting the wall, and they had told us to like find the mass of wall of the water hitting the wall like in 1.6 seconds. That was a bit confusing. I will also share
Or,
the like picture of this.
if you can share the year number, then it would be ideal. So we can open it here. Or picture is also fine if you can share the picture. And ideally, the year number is beneficial because then we can open it on the screen. But even picture is fine. Now, let's look at this first question. Nuclear physics is always at the tail of the syllabus, and it comes in the end. An experiment in which alpha particles were deflected by a gold foil. I'm taking a bit old question, and it's before 2016. Syllabus was much updated in 2016, and then it was updated in 2022. Before 2016, syllabus was updated in 2007, and then before that, it was 2002. And this is necessary to tell students in this time, end of just like the last 10 days of March and then April, that there is a syllabus change always. And after 4 years, 5 years, they have a major syllabus changes. So when you look at the past paper questions, especially in this chapter, you will find a big difference between these questions and the questions after 2016. Now, you have to see the first question, first MCQ. And you can bring your MCQ book, and if you get it there, if you get the same question, you can work on it. You can work on the paper. If you have a book, you can get it.
The book has all questions like mixed up. It doesn't have them separately, so I think it will be very
No,
hard to find.
but I think you have a topical past paper also, right? MCQs or not?
Yes, but they're after 2013.
Oh, acha. It's okay. You can look at the screen. An experiment in which alpha particles were deflected by a gold foil produce new insights into the structure of the atom. And I hope you remember he's talking about, examiner is talking about nuclear atom. So Rutherford made this experiment. And if you remember, this experiment was famous because it discovered nucleus inside an atom. Which conclusion can be drawn from the results of the experiment? Do you remember the conclusions of Rutherford experiment? There were 3 main conclusions, or at least 2. The first conclusion was that in every atom, there is a very dense, very small, positively charged nucleus. Second, majority volume of an atom is empty. Majority volume of an atom is empty. And the third optional case is electrons are not inside the nucleus, they are outside it, the leptons. Now, this is a type of elimination question. Atomic nuclei occupy a very small fraction of the volume of an atom. The second, electrons orbit the atomic nucleus. This was not directly concluded from Rutherford, the B. Some atoms of the same element contain different number of neutrons. This is a right point, but was it drawn from the experiment? The answer would be no. The atomic nucleus contains protons and neutrons. Now, because this experiment was actually discovering nucleus. So this, even though D is right, but D was not concluded from there. C is right, but it was not concluded from the experiment. Even B is right, but B was also not concluded. The experiment mainly concluded that there is a nucleus in every atom. So we mark A. Now you see this one. Nuclear decay is both spontaneous and random. You see this and you see this. This topic they have shifted in A2. So I am leaving this MCQ. Random and spontaneous, that term is not in our requirement now. They have shifted it to A2. Now you see this question. Thorium-234 decays by beta emission into a daughter product, which in turn decays by further beta emission into a granddaughter product. Which letter is in the diagram represents the granddaughter product? Did you notice that in this question, he is not identifying beta plus and beta minus? In our old syllabus, actually there are two betas, beta plus and beta minus. In old syllabus, it was only beta minus. So that is why he is not marked any letter. This is a 2012 question. And this is the benefit of doing some old questions with syllabus knowledge, that you know that it was a time when it was only beta minus. Now, can you recall for me what is the equation for alpha decay? You can look at that equation sheet. I have shared a sheet in which 3 decays are mentioned. I'm first talking about
beta minus, it was reduced by 1, the proton number.
No, I'm asking about alpha.
Alpha was helium nuclei 4-2.
Yes. Was there any particle like neutrino and any other particle released in alpha decay? The answer is no. No other particle, extra particle is released. Now, can you recall, you can always look on those sheets and this will be helpful. Can you recall that, what about beta decay? If I write beta decay, this is alpha decay. Now, for beta decay, mass number does not change. Atomic number increases by 1. Atomic number increases by 1. Now you see this one. Now this is beta minus. I write 0 in the top and -1 in the bottom. Can you recall for me what is the particle? Is there any particle release in beta minus decay? You can look at the equation sheet.
There was photon and neutrino.
There is photon and neutrino is symboled as this.
Yes,
This
S plus.
And what are the numbers on neutrino? Can you recall the numbers on neutrino? I have written it already.
Zero is the number of the neutrino.
Okay, so can you recall again that 00, I have written it. But can you recall for me that for beta minus, it is neutrino or anti-neutrino? You can always look on the sheets for references.
For beta minus, it is anti-neutrino.
Very good. So now we have corrected our equation. It's beta minus. I haven't shown gamma because gamma is an understood photon and it is not going to change atomic number. He has used a word granddaughter, which means it is a second decay. Now he says by beta emission into a daughter product, which is decayed by further beta emission into a granddaughter. So how many decays are there in this question?
2 decays.
So if I decay twice, you can see mass number, no change.
The proton number will decrease by 2.
Proton number increases by 1 in one decay. So proton number will increase by 2 because he's talking about granddaughter. So what is the mass number? Mass number you can see here, it is 234. So will 234 remain as it is?
Yes, it won't change.
Good, it won't change. And what about atomic number?
Atomic number for the granddaughter will increase by 2.
Very good. So granddaughter atomic number is presently, initially it is 90. So I plus 2 in it and I will get 92. So it's 234. It's 92, 234 as a coordinate. So the answer would be B.
B.
Radon Rn is the start of a decay chain that forms bismuth Bi by alpha and beta emission. For the decay of each nucleus of radon, how many alpha particles and beta particles are emitted?
There will be 2 alpha particles.
Now remember that in alpha decay, mass number decreases by 4 and atomic number decreases by 2. If I say here, radon 86, 86 has become 83. So how can I involve alpha and beta both? If I start from 86 and I'm going down to 83, it looks that there are 2 alpha, as you said, 86, 2 alpha will be 84 or 83. What will happen after 2 alpha? 1 alpha is minus 2.
So it will be 82.
It will be 82. After that, how can I get back it to 83?
By beta negative decay.
By beta minus decay, and it will become 83. So it means 2 alpha and 1 beta. Two alpha and 1 beta.
B will be the answer.
D. You're talking about B for bat or D for duck? I'm actually listening error.
B for bat.
Okay, good. Now it's perfect. Now you see this one. A class of students use dice to simulate radioactive decay. After each throw, those dice showing a 6 was removed. The graph shows the results. A dice has one till 6 numbers. So they are playing a dice, and after each throw, those dice showing a 6 were removed. So the dice which were showing 6, they were removed. What could the scatter of points about the best fit curve represent? You can see the words here. Sorry. You can see the words here that these words are not required now. So I left this question. A nuclear isotope emits radiation which is detected by a GM tube held at a distance of about 10 centimeter from the radioactive source. The radiation is stopped completely by a 2 millimeter thick sheet of lead. Lead is a universal interceptor. It can stop every type of radiation, including gamma. What can be deduced from this information about of emission from the isotope? Is specifically giving a separation of 10 cm. If the separation is 10 cm, can it be possible that alpha are also there? Can alpha travel 10 cm in air?
No, it can't.
No, it cannot. Okay.
Beta can travel like 50.
Beta can travel definitely 10, but he's very cleverly giving a very short distance, and he's giving another number, 2 millimeter. Can 2 millimeter thickness of lead, can it stop gamma completely?
No.
Now this is a clue. It cannot stop gamma completely. So there is no surety gamma was there or not, because if gamma was there, it could not be stopped. It could not be stopped. It could not be stopped by 2 millimeter thickness of lead. So gamma is not confirmed. First, I do elimination. I cannot select D because D is offering all of them. All of them is not possible. We have to exclude gamma. It could be a part, it could be alpha and beta, but not gamma. This is possible. Gamma cannot be stopped by 2 mm. It could be alpha and gamma, but not beta. This is wrong because beta can easily travel 10 cm. So now the tie is between A and C. It's a very close match. That is why examiner has given a very tricky number, because in our memory, alpha particles can travel in a range of 5 to 10 centimeter. Alpha can penetrate in a range of 5 to 10 centimeter. So now, whom should we give a benefit of doubt? Should we consider alpha to be not possible, or we have to exclude gamma?
Won't it be gamma because it has also like said lead? Because we know it can be stopped by lead gamma radiations.
Yes, gamma, but it's 2 millimeter only. The problem is that gamma needs to be stopped by a thick sheet of lead. 2 millimeter, it's even like a paper. That's a tricky part. Now the tie is between A and C. Now you have to decide carefully that beta cannot be excluded. Beta should be there. So beta is present in both. The game is between alpha and gamma. Now alpha has this range. So can alpha be given a chance that alpha can travel till 10 centimeter and it is detectable by the GM tube? Do you remember
Yes.
the concept that gamma rays are not easily detected by GM tube? Gamma rays are not detectable completely by a GM tube because gamma rays are not ionizing particles. So now we have to give a benefit of doubt to alpha because alpha can reach at maximum 10 centimeter. You can see the cleverness of the examiner when he's using a word before 10 cm. So the word is about 10 centimeter. So that is the point, and the answer is beta. A part. Which statement about alpha, beta, and gamma radiation is correct?
Alpha does not have the greatest ionizing power.
Ionizing power goes from the charge. Ionizing power goes with charge. Now, do you remember the inequality for ionizing power?
Yes, the alpha had the greatest ionizing power.
Yes, that's a clear shot because it's an easy question. It's a memory. A material contains a radioactive isotope that disintegrates solely by emission of alpha particles at a rate of 100 per second. Which statement about this material is correct? Now, this is a very technical question that when decay occurs, a particle or element converts into a daughter element. It converts into another element. Now, this is number 8. You have to see these options, just like 100 per second. 100 per second. Now you see that question is tricky, but if you read this question part alpha, is it right that alpha is 4, 2? Alpha is like helium nucleus, it is 4, 2. So when an alpha particle goes out, can you tell me what is the change in nucleon number? When alpha decay occurs, mass number or nucleon number decreases by 4 and atomic number decreases by 2. Right? Now we know this idea. Number of atoms in the material diminishes at a rate of 100 per second. This is a technical question that actually decay is not something related to atoms. It is related to nucleus and particles inside the nucleus. Atoms are not a concern in this chapter because atoms do not decay, nuclei decay. So the first option is rejected. The number of neutrons in the material diminishes at a rate of 100 neutrons.
Protons will also be there.
Yes, number of nucleons in the material, diminishes by 400. So I ask you a question, if I remove 1 alpha, how much mass number will decrease?
4.
4. So if I remove 100 alpha, mass number will be subtracted by
400.
400. In that sense, there are 400 diminishing per second. This is possible. The number of protons in the material diminishes at a rate of 100. It is wrong because Z minus 2. It should be 200 because every alpha particle will cause a loss of 2. So for 100, it should be 200. So I have cancelled this. Now I have a tie between B and C.
So it would be C.
Yes, good guess, that is C. Then why B should not be taken? Because B says number of neutrons in the material. Now this is a technical issue. It's a radioactive isotope. It's a radioactive isotope, so number of neutrons can vary. So we do not know. We do not know the number. We can guess for proton, we can guess for nucleon number, but we cannot guess for other. But one thing is sure, it cannot be 100. It should be something bigger than 100. What remains constant during beta emission from a number of identical nuclei in a substance? If you remember beta emission equation, XAZ gives you YA Z plus 1 plus beta minus 1, 0 minus 1 plus anti-neutrino.
So nucleon number will be the same.
Nucleon number, very good. So that's a good point out, because that was giving a good chance, good scoring way. Nucleon number does not change in a beta decay. In a radioactive decay series, 3 successive decays each result in a particle being emitted. Each result in a particle being emitted. The first decay results in the emission of a beta particle. The second decay results in the emission of an alpha particle. The third decay results in the emission of another beta particle. Now, this is to need some working. The first, you can say A does not change. Z plus 1, then A minus 4, Z minus 2, then again A, whatever A is now left over, and Z plus 1. I have marked the changes. Remember, in the earlier questions, the beta word means beta minus 1. So nuclei P and nuclide P and S are compared. So this is P, this is S. Now, can you tell me that there is 1 alpha and 2 beta? Do you think the Z will come back to the same value?
Yes, because minus 2 will be compared with plus
Yes,
2.
because plus 1 minus 2 plus 1 will be equal to 0. So it means Z has no change overall. What about mass number? No change, then a change of 4, then no change. So can I say overall it's a change of minus 4?
Yes.
Okay, now you can work out the options. Question number 10.
It will be B.
Yes, very good. Isotopes of the same element. Same element, why? Because Z is not changing. A different nucleus can be formed by bombarding a stable nucleus with an energetic alpha particle. We have to leave this. See this one, the graph of neutron number against proton number represents a sequence of radioactive decays. Nucleus is X is at the start of the sequence, and after the decays have occurred, nucleus Y is formed. You can see if I talk about X, he says that X is the parent nucleus and Y is the daughter nucleus. Now, if we make the sequence, mass number goes, nucleon number goes down. Nucleon number goes down first by 2, then another 2. Overall, I can see here that this is the drop of -4. But can you see atomic number has returned? Atomic number is 84. 84 for Y, 84 for X. It means atomic number has returned and mass number has an overall decrease of 4. How come atomic number come back?
Beta minus emissions.
Yes, beta minus emission. You can see if I portray this part, it's a decrease of 2. And if I portray this one, it is an increase of +2. Now, these are the options.
B will be the answer again.
One alpha and 2 beta, because there is only one Y. When you
B
say,
B.
sorry, you are
I
saying
said 1 alpha and 2 beta.
Acha, haan, B and D are very close. Yes, you are possibly right. A and C are wrong. When the Z is coming back, it means 1 alpha and 2 beta. That makes sense. But how we decide, we can see the diagram. You can see the diagram to distinguish between now you see this diagram. The particle went down to 82 and then came back to 84. If you see the trail of Z, if you see the trail of Z, it is 84 to 82 and then came back to 84.
So first alpha emissions occurred.
We have to see carefully that how it's -2 and +2. It cannot be. We have to see carefully. Then you are looking right because 1 alpha will cause, देखो 1 alpha will cause a -2, it will become 82. And then this is 1 alpha. Then 2 beta will cause a +2 and 84 comes back. Then it means B is the right answer. A nickel nucleus, Ni, can be transformed by a process termed K capture. In this process, the nucleus absorbs an orbital electron. A nickel nucleus F5928 can be transformed by a process termed K capture. The process nucleus absorb an orbital electron. If no other process is involved, what is the resulting nucleus? We can try to write its equation. Nickel 5928. If I write electron E0 minus 1, so can you help me to write in the equation? Whatever I will get 59
and 29.
and 29 or 27.
27.
Okay. Then
C will be the answer because it says plus minus. That is why it will be minus.
yes.
Because I was thinking on the beta negative terms. That is why I thought.
But beta negative means the same, na?
Hmm.
In this process, nucleus absorbs an orbital electron. Orbital electron is E minus 1. So then you write it's C.
If it was beta negative, then the answer would be D.
Beta?
Negative decay.
No, make it clear. It's not emitting. It's absorbing. There the examiners are always trying to trap. Beta particle, if emitted, then it's a memory question. It's an absorbing. So even if it's beta, it would be on the left-hand side. When beta would be on left-hand side, then still beta particle is an electron. You will get the same answer. He's trying to trap. It's not a beta decay. It is a beta absorption. Scientists investigating the count rate from a radioactive source. We have to leave this. It was once thought that the mass of an atom is spread uniformly through the volume of the atom. When alpha particles are directed at a piece of gold foil, the results led scientists to believe instead that nearly all the mass of the gold atom is concentrated at a point inside the atom, which effect is possible only if nearly all the mass of gold atom is concentrated at a point. How you can, which of these points justify that majority volume of an atom is empty?
C.
Some alpha particle pass through without any deflection. Do you agree with the word some?
No, most of them will pass.
Yes, he is trapping you. You're reading it rightly, but they are experienced in trapping. The after the word some statement is right, but it should be majority, not some. Some alpha particles are absorbed. That doesn't make any sense. Most alpha particles are only slightly deflected. This is a possibility. And all the mass of the gold atom is concentrated. When you concentrate all the mass at one point, that point will be very dense.
Yes, it will be dense.
And this is an alpha particle coming. So that point will be so dense that will it actually bounce back the alpha particle?
Oh, yes, like the 2, 3 we saw in the diagrams, they were coming back. So A will be
Yes.
the answer.
Yes, A will be the answer. What is the approximate mass of an alpha particle? How we can calculate alpha particle mass? Its mass is actually 4U. So can you recall what is U in kg? Is it 1.66 or 1.67? I have a memory issue here. Power is fine, but was it 1.66 or 1.67? You can check it and you can calculate this.
Electron mass will be like not considered.
No, electron mass is not required. Alpha particle is 4U. You have to, like the chemistry one, and you have to convert it into the standard mass.
From this, it is coming 6.68 into 10 power minus 27.
But it's not matching with anyone. You are seeing 10 power minus 27.
Yes.
27 is close to B and A. Now, so I can cancel C and D, and I am now left with A and B. Can you check the how much is the whole number? 10 power 27 minus 27, and before that?
6.68.
It's a very tricky part. 6.68. It's very close. Now it's in between. Now this is a very close tie, and actually there is no particular clue he has given. He's using the word approximate, and approximate wise, no, it's not making any sense, because it can be minus 26, it can be minus 28, because he has not given the number. Maybe he has not given the number before 10 power. It's either A or B. Now there is any clue? No. Now I have to see it later, because no clue is coming. Maybe there is some error and something like that. Because if it's a memory, then it's fine. But alpha particle mass is. Can you check the value of U, unified mass constant? Am I using it correctly? Okay, let me check later. This is still in a problem. The decay of a nucleus of neptunium is accompanied by the emission of a beta particle, means beta minus particle, and gamma radiation. Gamma radiation does not alter. Gamma radiation does not alter atomic number. Gamma rays do not change atomic number. What effect, if any, does this decay have on the proton number and on the nucleon number? in a beta decay, mass number decreases by 4, atomic number decreases by 2. But what about gamma? Gamma has no effect on atomic number.
So the nucleon number will remain unchanged and the proton number will increase.
In beta decay, there is no change. Achha, sorry, I have made a mistake. In beta decay, A has no change and atomic number increases by 1. So 17, what should be the answer then?
D.
Yes. Which pair of nuclei are isotopes of one another? Nucleon number, number of neutrons. Number of neutrons can vary. We have to take out isotopes of one another.
So C.
You're looking at number of neutrons, but how neutrons, proton number should be the same. Proton number should be the same, not the neutron number.
D will be the answer.
But D is nucleon number. Nucleon number change.
So the definition was a different number of neutrons and same number of protons.
No, definition was different number of neutrons. Different number of neutrons and same number of protons.
So the nucleon number will change and the atomic number will stay the same.
One thing is sure, the number of neutron can change. They shouldn't be the same. Number of nucleon number is not actually, we should try to find atomic number, Z. You know how to find Z?
So it will be the neutrons plus the protons.
Yes, and other way you can say that nucleon number is proton. Nucleon number means proton plus neutron, and this is only neutron. So if I subtract 186 minus 112, I will get the proton number. The main thing is required proton number.
74 for the one above. Then it is 62.
So atomic number is changing. They can't be isotopes.
Then it is 74. For both of them, it is 74.
Oh, then we reach the target. If we getting the same atomic number, then B is the answer, because isotopes are those which have a common atomic number. An actinium nucleus has a nucleon number of 227 and a proton number of 89. It decays to form a radium nucleus, emitting a beta particle and an alpha particle in the process. What are the nucleon number and the proton number of this radium nucleus? Emitting a beta particle and an alpha particle. Beta means Z plus 1. Beta means Z plus 1. Alpha means Z minus 2. Overall, it's minus 1. Overall, it's minus 1.
So B will be the answer.
88. because this number is 89. 89 minus 1, 88. Because when you say plus 1 minus 2, it's actually equal to minus 1. A radioactive nucleus is formed by beta decay. This nucleus then decays by alpha emission.
So won't B be the only right option?
Why?
No, no. That's the nucleon number on top.
Right. And mass number is, and atomic number is on n axis. B can be right. This nucleus then decays by alpha, first beta and then alpha. Beta means plus 1. Here in this initial chapter, initial part, beta means Z plus 1 and alpha means Z minus 2.
So this can also be right actually.
B is possible. Actually, A can't be because in A, atomic number is decreasing all the way. So it's not possible. In C, atomic number, even in C, atomic number is decreasing. So there's only one option where atomic number first increases and then decreases.
That's B.
Yes. So that you are right in the start of that question. So we did some old questions today, and this is how we have to prepare, because old questions are also there in some chapters. Old questions are very different. So we keep it up to here, and we will, and onward, we can set a topic. I can post you, and you can make some quick work on that, and we can do it, because topical needs some more attention, especially MCQs. So we keep it up to here, and we will, inshallah, continue it in our next class. Allah Hafiz.
Allah Hafiz.